distribute mean again?
To multiply.
Yes. And we know it's multiplication because there's no symbol in between the -2 and the parentheses. There's not an addition or a subtraction sign. So it means that we need to multiply. So -2 times x is -2x. -2 times 5 is -10. And then we bring the rest of it down. We don't do anything with this part yet except for rewrite it. Now we look to see if there are like terms. What are the like terms?
-2 or -2x and +7x.
Okay. So -2 plus 7 is 5. So we have 5x. What else is like terms?
-10 and -10.
So now we can put these together. Well, -10 minus 10 is -20. Are we done? Are there any more like terms? No, good. Guys, it's very important that you understand right now, you cannot do 5 minus 20. You cannot. This is being multiplied times x, this is not. Okay? So we're done. Now, factoring means we work backwards. So we basically take an expression like this and we put it into distributive property form where you would need to distribute, and we can go back and forth. Is there a greatest common factor other than 1 with 5 and 20?
5.
5, yeah, we can divide both of those by 5. So when we're factoring, we're going to write the 5 on the outside of the parentheses. We're pulling it out. What do we need to multiply times 5 to get 5x?
1. X,
1x.
1.
X. 1x, just x. So now we're thinking backwards, right? What do we need to multiply times 5 to get -20?
4.
4.
So
-4.
who said -4? Who said that?
I think it was Michael.
Michael, you're
It's
right.
not me.
Well, I
It
don't know
wasn't
who it
me.
was. I'm just trying to get you
It
to
wasn't
here.
me.
Don't be scared to say that it's you. It is a -4. Yeah, you guys got to be careful, okay?
I forgot there was a negative.
You'll get it wrong if you don't. You got to attend to precision. Be accurate, okay? Now, we have just factored the expression and we generated a new expression, right, that is equivalent. They are the same. These values are the same. We just wrote it in a different way. We undid a distribution of 5. So to check it, again, it's all about checking your answer. I don't know if we made that clear in that last example. You have to check it. You've got to take whatever you come up with and work backwards to see if you end up where you started. You've got to check, okay? Mistakes are going to be made, guys. They're going to. It's okay to make the mistakes. I still make mistakes when I solve equations, and I've been doing it way longer, right? But that's why you got to check your work. So to check it, you would then distribute your 5 and see if you come back to this. You distribute, you get 5x minus 20. And a lot of you are going to be like, yeah, I can do that in my head. I don't need to write it out, Ms. Hosta. You can't. I mean, you probably can, but Mistakes get made when we do stuff in our head, okay? So just don't be lazy and take a moment to just write it out. So we have used the distributive property. We have combined like terms. We could have rewritten this and put the 7x next to the negative 2x and put the negative 10s together using the commutative property. But honestly, I find this to just be, I mean, it's just faster, right? We didn't have to rewrite the whole thing just to put them certain things next to each other. Just use like lines to show that you're putting these together to get that, you're putting these together to get that. But it's the commutative property that really would allow us to do that. And then we got an answer. We put a box or circle around it. We then were able to apply the factoring expressions lesson to this because they had a GCF of 5. And so we pulled that out and we rewrote it this way. Let's do a couple more examples and then I think you guys are ready to do your quiz. I wanted to look at, yeah, you guys, for your quiz, you can reference your notes. I want to see, it's just been, yeah, it's fine. Notes are fine on your quiz. I'm trusting you. Don't cheat or do anything else. Just reference your notes and apply it to the new problems. So let me, I had your guys' quiz up. Where did it go? Oh, here it is.
What if I'm done?
Well, I'm in a Zoom. Can it wait?
Oh, not me.
Okay. So let's do an example. So there are parentheses. Is there anything to distribute?
No.
How do you know?
No number.
Be-
There's no number that's outside of those numbers in the parentheses.
Yeah, there's no number sitting outside of the parentheses, right? There's a plus sign here though. Did you guys, I taught you that there's actually a number here with this symbol. What is it?
1.
1.
Yes, it's a 1. So, but it'd be silly to distribute a positive 1 because then you're just multiplying these times 1 and that doesn't change anything. So that's pointless, right? So you don't need to do that. What we can do is just drop our parentheses and combine like terms. So really we're just working with negative 3x minus 12 plus 12x plus 6 because these numbers stay the same. They're not changing. Now we look and go, okay, we can put negative 3x and 12x together. That gives us 9x. 12 minus 3. We can put negative 12 and 6. That gives us, oh, I put a plus. It's actually a negative. Negative 6. This one worked out nicely too because we can actually factor this one and get some more practice in with factoring. What's the GCF of 9 and 6?
3.
Mm-hmm. So we're going to pull out a 3, write our parentheses. 3 times 3x gives us 9x. And 3 times negative 2 will give us negative 6. So we have our simplified expression and we have our factored expression. All right, let me see what else I want to go over. There was a lot of work done with writing expressions and understanding the language. You will have to, well, actually, it's written for you, so you have a real world scenario. The equation is written for you. You're rewriting the equation in another way, and it'll make perfect sense to you, I'm sure, once you see that, what you need to do to write it a different way. Oh, this one's still funky. I thought I changed this. Darn it. That doesn't make any sense. On screen 5, I'm just looking, the formatting is a little off. So you'll want to, well, you'll rewrite it anyways. You're gonna show your work in the thinking box, okay? That one's a factoring one, so we covered that. Okay, I got one more that I wanna go over with you, and then you will be ready to go. We did one like this, and we talked about how there's nothing to distribute because there's no number on the outside of the parentheses. But if we put a negative here, that is going to change what's in parentheses. Because this is a -1. So in this case, we do need to distribute this -1. It's going to make these the opposite. So this side would stay the same. This would now become a -5x, and this is now a +2. Any questions on how I got that? This side. Okay. We combine like terms like we normally would. -3 minus 5 is -8. -12 plus 2 is -10. I can factor this one. GCF is what?
2.
It is. And actually, because both terms are negative, the GCF is -2. If both of them are negative, you want to pull that negative out with it. So we're going to pull out a -2. -2 times 4x gives us 8x, or -8x. -2 times +5 will give us -10. So this is the factored form. Now, you might wonder, does it really matter if I put the negative and pull it out? Yes. Mathematically, it would not be incorrect if you did 2 times -4x minus 5. You're still going to result in the same expression. But if both of them share that negative, fully factoring means you pull it out. Because what you're saying is it's a -1 times 2. That's what makes it a -2. And so you need to pull that negative out with it. Mathematically correct, but proper, no. Proper means, you need to pull it out, okay? I think you guys